Okay, tell me something about yourself in brief.
Good afternoon, sir. My name is Chhatrapati Kamalnan Hazarika. I am from Assam. I completed my bachelor's in chemical engineering from Assam Engineering College. I did my industrial training at IITS Digboy, where I received excellent feedback due to my diligence. I'm a very down to earth and congenial person, so people tend to feel comfortable making conversations with me. And throughout many years, I have been trying to teach myself various technical skills, and I'm still seeking to acquire more. Um, I won't call myself a voracious reader, but I try to read as many books as I can during my free time. And cycling and photography are some of my other hobbies as well.
Okay, great. So, like, आपको novels, books पढ़ना पसंद है? Which book you read?
Yes, sir.
The last book
Uh,
which you read?
Sir, the last book actually what I read was a fiction novel actually, sir, of Lord of the Rings. And previously I read about uh, a man's meaning to life by Viktor Frankl, and it was really inspirational.
Oh, great. So you are like the bookish person.
Not exactly, sir. I just try sometimes.
Okay, great. Tell me your favorite subjects for the interview.
Sir, mass transfer, MTO, HTO, FM, and thermo.
FM, thermo, mass transfer, and
HTO.
okay. So can you tell me the how mass transfer take place?
So mass transfer takes place from one phase. Is a transfer of a mass from one moles or mass from one point to another point in a same phase, or from one phase to another phase due to a driving force that is present.
Okay,
Mainly
great.
concentration difference, sir. Yeah.
Okay. If I use the room freshener in my room, how the smell of the room freshener is spread in my room?
Sir,
Tell me the
if
phenomenon.
there is yes, sir. Yes, sir. If we keep a room freshener at one corner of the room, we still smell it fresh because of diffusion taking place from the liquid element of the room freshener to the atmosphere, and we can smell it through by inhaling it through our nose.
Okay, what is the requirement for the diffusion?
Sir, diffusion requires two basic principles. One is obviously driving force it will require, and one will be like the mass transfer coefficient which we use, and it could be in the form of solubility, sir, and in any temperatures also, and lots of variables.
Okay, like it's not depend upon the concentration.
Yes, sir. So that's what I mean by driving force. Since there is no other particles in the air, so obviously since the concentration is high in the liquid element, then obviously it will come from the higher concentration to the lower concentration, which is air.
When I use room freshener in my room, in the starting it diffuse in the room. That like after some time it will stop. Why?
So because if we give it to diffuse for a lots of time, then obviously there can be two reasons. For first of all, that concentration difference may be disappeared, so that's why no possible, and obviously the fluid element will also extinguish itself, so there will be no more to spread into the air, sir.
Okay. So like if you go thermo, okay. What the basic difference between vaporization and boiling?
Sir, boiling, vaporization can take place at any temperature. For example, if we keep water in a glass, then it will automatically vaporize into air slowly. And boiling is takes place in a bulk phenomena. So a critical temperature and pressure value has to be reached for it to start going into the vapor phase in a big bulk amount.
Okay, boiling में there's like temperature difference बढ़ता जाएगा. There's like
Yes.
if you increase the temperature difference, there's some certain phenomena in the nuclear like the boiling.
Yes, sir.
Which are the phenomena? Can you tell me?
Sir,
How
the
boiling start? How
yes,
boiling
yes.
the boiling start? Yeah.
Yes, yes. So, sir, law of boiling states that to start for a mixture to start boiling, the pressure exerted by the vapor should be equal to the atmospheric pressure. So, since it's a mixture, we have to keep on increasing the temperature. Like in a pure component, we have when it starts to vaporize, the temperature of the liquid phase does not change. But in case of a mixture, we have to keep increasing the temperature for the boiling to keep continuing, sir.
Okay. Now, do you have notebook and pen with you?
Yeah. Yes.
Yeah, draw the boiling curve.
Okay.
Like for that, you have to like remove your.
Yeah, yes, sir. 1 minute, sir, please.
Yeah, take your time. Okay. So this is your boiling curve.
Sir, yes, this one. The TXY diagram, boiling curve of a mixture.
Okay. No, it's a simple pure substance. For the pure
For
substance.
a pure substance, yes, sir.
Yeah.
Sir, it will be like this.
Is this boiling curve?
So this one.
Do you
Yes,
know
sir.
about the boiling? Do you know about the boiling curve? Do you hear about the boiling curve?
Sir, I know about the TXY curve for the boiling for pure components as well as mixtures.
Okay, I give you some hint. There's a like boiling curve we define as the pressure difference between substance and the liquid, surface and the liquid. And there's a at the vertical axis we call like heat flux. Can you recall? Heat flux versus temperature difference graph.
Heat flux versus temperature difference. So, sir, I'm having difficulty recalling it, sir.
Okay. So in vaporization, which formula is dominating? Or like, okay, I will each the question. Which diffusion take place in vaporization?
Diffusion takes place in vaporization. So diffusion, sir, sir, no. So it just goes from the liquid phase to the vapor phase. I mean,
No diffusion.
so so obviously there will be some diffusion. Like if in a mixture, then some
No, it's not
more
like
part.
it's not like mixture. You put butter in an open bowl in
Yes,
your
sir.
room.
Okay.
How vibration take place in your room at a normal temperature?
So in a normal temperature, it's it will be it will be acting some vapor pressure. So obviously, then it will
Vapor
take
pressure. Vapor
yes, sir.
pressure.
Yeah.
At the room temperature, you have the just normal room temperature. How vapor pressure create at the room pressure?
Sir, vapor pressure will be at any temperature above the absolute zero temperature, sir. So that's why evaporation can take place. Like evaporation,
Like how evaporation phenomena take place in your room? Just take a simple situation.
yes. So when liquid element gains some heat, it will try to escape from its liquid
From
phase to the vapor phase.
liquid take heat from where?
So takes heat from the atmosphere, sir, yes, from the surrounding.
Already, if there is no temperature difference between the water temperature and room temperature, how it will take heat from the surrounding?
Oh yes, yes. Uh, uh,
Okay. Can you tell me the type of pumps?
there are two types of pumps: are reciprocating and centrifugal pump.
Centrifugal. Okay, great. So what's the difference between reciprocating and centrifugal pump?
Sir, we for reciprocating pump we use a piston to pump the liquid, and for reciprocating pump there is an impeller which increases with velocity and like yes sir, it pushes the slip.
Okay. So where we use reciprocating pumps?
So when we need more higher pressure, when we need to we our requirement is more higher pressure, then we use reciprocating, and when it's medium to low pressure requirement, then we use centrifugal pumps.
Do you know about cavitation?
Yes, sir. Cavitation takes place due to bubble formation, and the liquid tries to convert into vapor phase, so it affects the suction pressure coming into the pump.
Cavitation will take place on both type of pumps or some specific type of pumps?
Sir, cavitation can be in both, but I think cavitation in centrifugal pump is more dominant, sir. So we will require to take more precaution in case of centrifugal pumps.
There is no cavitation in reciprocating pumps.
Sir, there are, but since we just pump the liquid through a piston, so there will be no accumulation in the pump. So that's why less cavitation will occur.
As cavitation. Cavitation at which at like on which type of like at that point cavitation take place? On suction or on discharge?
On some suction, sir.
So suction also happen in the reciprocating pumps, no?
Yes, sir.
So why not cavitation at reciprocating pumps?
Sir, we take the suction, sir. In case of reciprocating pump, we take the suction and we open the discharge as a. I mean, we accordingly, respectively. Okay. So, but in case of centrifugal, we can open that suction and later we can
label it. How you define NPSH?
Sir, net positive suction head will so it will measure the static stagnation head to the pressure head, sir.
Yes. Hello, Pankaj. Switch off your video. Yeah. So how you define NPCH? Can you repeat?
So NPCH is the pressure at the suction. We can define it by the stagnant head to the pressure head, sir.
Okay. What will what is the maximum suction head for a pump? So is there any limit for the pump at which height we can place the pump?
Yes, sir. It will be the limit will be given to us by the manufacturer, sir. Like they will term it as NPSH A, sir. So if we are to use the pump, we cannot go access to it, or else cavitation will take place.
Okay. Great. Okay, how you define like the drag force? You know about the drag force?
Yes, sir. Sir, drag force. We can define drag force as a phenomena due to is a property of a fluid to resist the flow when it's in contact with any surface, sir.
Okay. What's the difference between the friction drag, the friction force? You know the friction drag in pipes?
Yes, sir. Friction, sir. When due to the flow of the fluid in the pipes, there will be some friction occurring in it, so that opposes the movement of the fluid, and it will create some drag force, sir.
Okay, if we add two pipes in parallel or individual series, So which quantity will be same in parallel combination and series combination of pipe?
Sir, in parallel, whatever the discharge is coming out from the single pipe which diverts into two different parallel pipes, that will be the sum of the discharge of the two parallel pipes. And sir, in series, it will be the same Q1 will, for example, if Q1 diverges into Q2 and Q3, so Q1 will be Q2 plus Q3, and in the series pipe it will be Q1, sir, like that.
Okay, what will be the same in the parallel combination?
Sir, same.
What will which quantity is same in parallel combination?
Sir, the discharge is same. The sum
Discharge is
of the
same.
discharge is same.
No. In the both pipe, which quantity is same?
So I think the velocity.
Velocity. If discharge is different from both, how it is possible the velocity will be same?
Yes. So the head loss will be different, maybe.
Head loss will be different.
Yes, sir, different.
Okay. I'll leave it. In thermo, like which cycle we use in power plants?
So in power plants, we use exclusively Rankine cycle, sir.
Okay, guys. And when we use in our like room AC, which cycle is used?
Sir, in room AC refrigeration, so it will be like a reverse Brayton, I guess, reverse Brayton cycle.
And in the refrigerator?
So in the refrigerator, so it will be heat pump. So I think it will be a Carnot cycle, sir.
Carnot cycle is used in refrigerator.
Sir, I'm not sure, sir. Sir, about the refrigerator.
Okay, Carnot cycle practically possible है या नहीं?
Sir, it is not practically possible.
So we can't use this in our refrigerator, no?
Yes.
Okay, great. So what is the which steps are involved in reverse Brayton cycle?
Reversible isochoric and
Reversible
so isochoric, so constant pressure volume,
isochoric
and isentropics are adiabatic reversible.
सीरीज में बता सकते हैं आप? Tell me the series which process take place from which place to which place?
So first heat addition will take place in isochoric, sir, and after that expansion will take place in adiabatic, and then again heat rejection will take place in isochoric, and again compression will take place in adiabatic, sir.
Adiabatic in the real situation is isentropic process is possible or not?
Sir, so sorry, can you repeat it?
In the real cycle, isentropic process is possible or not? Isentropic.
Isentropic, sir. Yeah. Sir, no, it cannot be. Oh yes, sir, it can. I guess. I think.
Are
I'm
you
not
sure
sure,
it
sir.
is
I'm not
not?
sure.
Okay. Have you ever take any flight? aeroplanes?
Sir, no, I think it will be my first when going to NPCIL interview.
Oh, great. Then you have to learn which cycle is used in the cooling of aeroplanes. Okay.
Yes, sir.
Okay. How aeroplane take place? Like when we use passenger planes, an aeroplane take place. How it will
Sir,
lift?
sir, it lives due to obviously fluid mechanics. Sir, in the from the, since we can from the Bernoulli's equation also we can derive that due to the increasing pressure, then the pressure increasing velocity, the pressure will decrease. So by that principle, the plane wings of the aeroplane will take lift, sir.
Okay. And the heat transfer. How like when you come to the heat exchanger, we use LMTD.
Yes,
What
sir.
the meaning of LMTD?
Sir, LMTD is a it's an actually ideal assumption we take to find out the accurate value of the heat transfer flux that is taking heat transfer flux that is taking place in the heat exchanger, sir.
Why we use log mean temperature difference? Why we don't take just mean temperature difference?
Sir, because in the entire heat transfer process, we at every point we can see that the temperature difference is different, sir. So we cannot take each temperature different in the entire process as like that. So if we take the mean temperature, that is a log mean temperature, we can get the
No,
accurate data of heat transfer
we can
flux.
say we can take simply mean temperature difference now. Why we use log?
Sir, because the path is so we have to take also take into consideration about the path that is taking place. So we take log, not average, sir. Emitting,
How how log make difference in that path?
sir. Sir, arithmetic, as far as I know, like sir, arithmetic mean we use it for the values that are very close to each other, and the log mean temperature, sir, I mean log mean we take it for values that are very variable, sir. At every point, it is very changing fast. So like that, sir. If the values are very different to each other.
Okay, great. Now we can conclude your interview.
Thank you, sir.
Okay, just give me a last question. What is the difference between LWR and PSWR?
Huh? Excuse me, sir. I didn't hear it.
What is the difference between LWR and PSWR?
LWR.
Okay, leave it.
Sir, I don't know.
फर्स्ट बॉइलिंग कर्व्स आप अच्छे से पढ़ के जाइए.
Yes, sir.
बॉइलिंग कर्व सबसे ज्यादा पूछते हैं. बॉइलिंग कर्व्स में कैसे हीटिंग होती है, किस तरीके से काम करता है. बॉइलिंग कर्व, कंडेंसेशन कर्व पढ़ के जाइएगा.
Yes, sir.
फ्लूइड मशीनरी में वही है, पंप्स है, बिजली आप वो पढ़ के
Yes,
जाइएगा कि वो मोस्टली पूछते हैं.
yes, sir. I have
थर्मो
not
में
studied fit right now. I have
and
revised.
thermo में you have to revise all the cycles,
Yes,
thermodynamic
sir.
cycles.
Yes, sir.
Which cycle is used and कहाँ यूज होता है, their applications.
Yes, sir.
Okay,
Definitely.
चलिए.
Thank you.
Work hard.
Thank you, sir. Thank you.
Okay.